So for nesting, we have a feature called auto task. So all that does is SigmaNEST recognizes that we have a range of materials and thicknesses, and it's smart enough to know that, as we create our nest or what we call a task, um, that we're cutting out like parts or like material and thicknesses here. So it will automate some of this setup for me in the background. So these tasks were just generated. So if I jump into one of them, it separated out the parts that are of that same material and thickness for actual nesting there. And it's done this for all of the materials that we've kind of were working with. And then there's ways to automate even beyond this. So we have automatic nesting. Of course, I can manually nest my part. I can drag and place and click it wherever I want.
Mm-hmm.
There's a feature in here so that I can't place them on top of each other, this little bump bubble, kind of rotating things around, that kind of stuff. But um, of course, auto nesting is going to be the meat and potatoes here and our
Yep.
nesting algorithms. So that's pretty quick. In this case, not too many parts, but we get everything auto nested there. There's different algorithms and different settings for controlling, our clearances in between parts or clearances to the edge of the sheet, whether or not you want to take into account the lead-ins here on your part. So we can see right now my bubble clearance is big enough that it doesn't matter for the laser, but if you have like a plasma or something like that, it might be a little bit more important. Um, so we can turn that on, and then we can see now it's adding in that little clearance bubble around them
Sure.
for me there.
hmm So when doing this, then can we have different settings or profiles created for, say, for nesting for the plasma versus the laser?
Yeah, so a lot of areas in SigmaNest, so the common ones are going to be your nesting and your NC settings, but things like lead-in parameters too, they're all saved per machine, material, and thickness. So even stainless steel versus mild steel, you might have different settings.
Yeah.
Thicker material versus thinner material, you'll have different settings. And then, like you said, your plasma versus your laser, you're going to have different settings. So yeah.
Yeah, it'd just be like you select your machine and then you select your material and you select your thickness, and then it has those settings saved for that combination in
Yeah,
there.
exactly. Yeah,
Mhm.
so in this case, the only thing I have to select is the machine that I want it to go to. Otherwise, it's going to read from the parts themselves. So
Yep.
it recognizes that the parts are stainless steel 3/8, and then it pulls in the settings for whatever that particular machine is. So if I change machines here, I should have plasma. There we go. And then I don't know if you noticed, but the values here are updated appropriately
Yeah, I
to
did.
my
Yeah.
plasma machine there. I'll switch it back, and then I can see
hmm
my laser values there, that kind of thing.
Great. Okay. And this can handle beveling?
Yes, yeah. So for beveling, there isn't anything special in terms of nesting you have to do. Let me see if I have a bevel part here. I should have some.
Yeah, I don't think I sent anything that was beveled, so apologize for that.
Oh, that's perfectly fine. And I'm just going to use step files, but bevel parts, the only thing you have to do is just turn on this checkbox, and that's really all there is to it.
Okay. hmm
And then they will get this balloon. Let me actually set them to my bevel machine here too. There we go. And then they get this little balloon that pops up with their bevel information, so you can kind of double check
Oh.
what's coming in is appropriate. And um, there are ways in SigmaNEST to add bevels. So if you didn't do it in the drawing, or it's coming from a flat drawing and not the 3D file, I can come in here and add the bevel part, or excuse me, the bevel to the part. You just
Oh.
specify, the shape, the style of the bevel, that kind of thing. So that's pretty easy to do inside of SigmaNEST. Um,
hmm
and then there's tables in the background that we're reading for the bevels. So the things like the corner loops, the lead-ins, any kind of offsets that we need that are specific to the bevels versus your straight cutting, all of that's saved in your tables in the background. So in terms of if you have the geometry coming in correctly, there isn't too much you have to do with in terms of the interaction there for
hmm
nesting or preparing the parts. And let me get my test I created for my bevel parts, and we'll look at the bevel ones here. And again, for beveling, there's nothing special I have to worry about for nesting. it takes it into account automatically. So it recognizes it's a bevel part and it's on my bevel machine. So we need to add in my clearances there for all of my corner
Mhm.
loops and all of that for beveling.
I
So it
like how
handles
it's
that.
ghosting your clearances there so you can see
Yeah,
clearly how much space you need everywhere.
yeah, yeah. So it adds all that for you, and it takes that into account for nesting. So we're not going to nest parts we need a
Hmm.
giant corner loop or anything like that. It'll handle that stuff for you automatically.
Hmm.
There we go. And then in the NC side of things, I'm just going to focus on kind of the auto functions we have. But again, for beveling, there's nothing special we have to turn on. As long as it's a bevel part on a bevel machine, it picks that up and recognizes it automatically.
Okay.
But some of the things in here we're controlling is like our cutting order. So we're starting down here, working our way up and over, that kind of stuff. There's options in here for um, auto drilling. I'm not sure if your machine has a drilling head or anything like that, but we can do some auto drilling. There's part avoidance, which this controls the rapids of the machine.
Sure.
Um, some machines, once it starts cutting, then it can't lift the head up. So in those cases, we can wrap it around parts rather than over them if we need
Sure.
to reduce like collisions. For generally for most lasers, at least they have like a safety height and then their regular height. So
Yep.
it'll swap between those as it's kind of moving across the sheet to, again, reduce the chance of any kind of collision happening. If there's a tip up for whatever reason, the machine should at least be at its safety height,
Yeah.
kind of based on your parameters in here. We also can support um, profile destruct. None of these examples are going to show up, but if you had a feature cut out of your part here on the inside and you actually wanted to destruct it to make sure that it's small enough to fall through the machine slats, that kind of thing. Um, and then our crop cuts, these are fairly self-explanatory, but the sheet cutoffs here, we can do straight line, we can hug the contour of your parts, so you can save that leftover material. We can do some scrap cutting, which is very similar to profile destruct, but this would apply to the skeleton of your material and come in and destruct that skeleton area. So if you have like a material recycler, something you work with, and
Mm.
everything they accept is smaller than 4x4 or 2x2, whatever the case is,
So just
when the
cut your
skeleton,
skeleton down to
yeah,
smaller pieces. Yeah.
yeah, so it's ready for the operators. They don't have to cut it up or handle it afterwards and add those cuts themselves. It's done through the NC program.
Hmm.
We can also support common line cutting. This isn't a good example because these are bevel parts, but generally your more square rectangular shapes, we could nest them in a way that they're going to share cuts here more often on the lasers than plasmas because plasmas you'll have the one edge that's usually a lower quality, but we
Yeah.
could do it for either machine. There's in the software there's not a limitation there, and
Okay.
then some automatic tabbing as well. Um, so the style of tabs that you want, where the tabs are getting placed, how many tabs per part. Do you want 3 tabs, 2 tabs? Do you want tabs on just your small parts, like on your laser? Usually the small parts are the ones that give you a headache over the large parts, that kind of thing.